So let's talk about a series. A series is the sum of the terms of a sequence. So if a sub n generates the nth term of your sequence, you might have something that looks like this. A1 plus A2 plus A3. Suppose you're adding the terms of a sequence. Plus A4 plus, and then dot, 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 all the way up to the what we'll call the nth term, A subscript n. That happens a lot in computer science, in science in general, in physics in particular. You end up adding a lot of numbers together, and you don't want to write it down every time. In fact, when you have double sums, you have sums of sums, in other words, it becomes impossible to write it all down and keep track of it. So we have a shorthand notation for adding. Anybody ever use Excel in here? Yeah, what is that Greek symbol, sigma, represent in Excel when you click on the icon? Sum, yeah. And that's exactly what it represents in math. That's where they got it. It's represented sum in math way before Excel was around. So the notation we use, we call it summation notation or sigma notation. You'll hear me say it either way. So to represent this sum, A1 plus A2 plus A3 plus dot, 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 all the way to AN, we start off with a sigma. I don't need to be that far away from that side. We start off with a sigma. Let's start at, we use a letter for what's called an index, I. And we'll usually start at 1, although once in a while it'll start at a different number, so pay attention to that. Probably not in this section, but later on. So I equals 1. You don't know what that means yet. Don't worry about it. I equals 1 to, we're going to put the upper limit of the values. So I is changing. I starts at 1, but then you count 1, 2, 3, 4. And I is going to stop at n, the input that generates the last term. And then the symbolism that goes after the sigma symbol is the generic formula. I can't use a sub n here, so I'll use a sub I, the generic formula for the ith term of the sequence. Okay? So if you've never seen it before, this is a little bit strange. So the way we would read it is, we would read this on the left-hand side as the sum from I equals 1 to n of a sub I. And that simply means you add the first term plus the second term plus the third term plus the fourth term all the way to the upper limit, which would be in this case the nth term of the sequence together. Okay? This, you would say, is the sum from I equals 1 to n of a sub I. And again, it just means you're going to sum all the way to what is the nth term. So let me show you some particular examples in case you've never seen this before to really drive it home. So we're not actually going to compute the sum. We're going to write this out longhand. The sum from k equals 1 to 4 of 1 divided by k plus 1. So, by the way, I should have done this a second ago. Let's give this upper number a name. This number, this n up here, is called the upper limit on I. I is the index. 1 is the lower limit. That's where I starts. And I'll go ahead and write down that I is your index. Is it always going to stay I? No, it really doesn't matter what letter you use there, because when you actually compute the sum, it disappears. It's just an index. It's an indexing. It keeps track of where you're at. That's what an index does. Okay, so let's write this out longhand. The sum from k equals 1 to n of 1 divided by 2k plus 1. So notice I changed the index on you. I called it k instead of I. It doesn't matter, because once we write out the sum longhand, the index disappears. That letter, it's called a dummy variable also because it disappears. And the upper limit, the thing we called n in the generic definition, is now 4. It's a specific number. So how many terms would we expect to have in this sum? 4. And all we do is start at k equals 1, see what the formula looks like when you plug in k equals 1, then go to k equals 2, add that in. When k equals 2, evaluate the formula, k equals 2, add that in. Go to k equals 3, evaluate the formula, add that in, and so on and so forth until you get to an input of 4, and then you stop. So this would be equal to just, okay, 1 over, you start with k equals 1, so 1 over 2 times 1 plus 1, there's your first term. Now, we'll simplify that in the next step, but that's your first term. And then what do you plug in? 1 over 2 times, the input becomes 2 plus 1. That's your second term. 1 over 2 times 2 is your second term. 1 over 2 times 2 plus 1, rather, is your second term. What's your third term going to be? So 1 over 2 times 3 plus 1. And then your fourth term? 1 over 2 times 4 plus 1. Okay, and then we'll simplify the denominators, but I'm not actually going to add them together. So what do we get? 1 over 3 plus 1 over, oh, we're getting some odd numbers in the denominators, aren't we? 1 over 5 plus 1/7 for this third one, plus 1/9. And then that's, I mean, you could add those together by getting common denominators, but that's not part of the problem. I just wanted you to get some practice with this notation. Does the notation make sense now? Just a little, again, it's different, but it's not necessarily difficult. You just have to, once you wrap your mind around it. That's pretty much how math is, right? It seems hard at first, and then you wrap your mind around it, and it's not as bad as you thought. That'll be the slogan of this class. Not as bad as I thought.